everyone, how are you doing? Hi. Yes, we are approaching to the end. This is the last chapter and this is the second last section, okay? So, let's finish everything in terms of course material this week, okay? Alright, over here, today we do hypothesis test for population proportion P. And the other day we studied about the language of a hypothesis test. So there are two hypotheses. So if we change it to E, that becomes plural. H naught. Okay, we use the word naught. Is the kind of old data. Okay, in terms of timing was old, or in terms of like a system changed, so before the new system, or before the new system, or before any kind of a big event like a coronavirus. Yeah, they are going to do a lot of survey after things calm down. And so this is the prevailing old data. Okay, we are going to assume that is true until it's proven otherwise. Okay, so there are three types. One is that H1 says simply P is not equal to 0.8. It's a two-tailed because it could be larger than 0.8 or less than 0.8. Or this is right-tailed, that is P is greater than 0.8, or P is less than 0.8, left-tailed. We are going to see how we are going to separate those cases through our examples. At any rate, our conclusions will be just one of those two, one way or another. We are going to reject H naught, and we say, hey, it's time to change. Okay, so we do reject, but what I'm saying is just that is our kind of understanding. We never say that, okay? Just simply we reject H naught, or the other way around. That is, we do not reject H naught. Our vocabulary will be strictly stick to these two statements. Okay, we reject or we do not reject. But there is, once you see inside all possible cases, one is that we reject H naught when is still true. Okay, when it's true, we reject it. That probability is called alpha. We're going to use it so many times, so they give a name, alpha, the very first letter of Greek letters, alpha, and we call it level of significance. Yes, level of significance. We saw alpha before. Yes, we saw that level of confidence. At that time we use percentage. Yes, still we are going to have alpha, means we are going to use percentage to indicate that. Level of confidence was expressed as 1 minus alpha times 100%. So for example, if alpha is 0.1 or 10%, that means 1 minus alpha is 0.9. So that is 90% of level of confidence. That is related to what? Level of confidence is 0.1 or 10%. I'm sorry, level of significance. Yeah, level of confidence, level of significance. Two different things over here. And yes, when you talk about level of confidence, that is always this 1 minus alpha times 100%. So it is going to be like 99%, 95%, 90%, things like that. But level of significance is going to be like 0.1, 0.05, 0.001, things like that. Okay, so we are going to understand what we are going to do through the first example. So we are not going to do very precise computation, but we are going to understand the concept. Okay. A researcher obtains a random sample of 1,000 people. So that is little n is 1,000, and finds that 534, so we call it X, right? In favor of banning cell phone use while driving. Oh, I agree with them. Okay, so I'm one of those if I'm asked. Okay, banning the cell phone use while driving. Well, so what we do, this is a sample. So we found that sample proportion is 0.534. The next one I want you to underline that. Does this suggest that more than 50% of people favor the policy? This is slightly more than 0.5, 50%. I agree, okay? But is it good enough to say that, okay, to claim that more than 50% people are in favor of this banning cell phone use, okay? Yes. The thing is, if the difference is huge, well, we don't have to go through statistical, this hypothesis test. But this is close enough so that everybody is going to wonder, hey, this is just basically, okay, fundamentally just 50%, but what is so is just maybe just a little one outlier, just a little bit more variation, okay? So it is going to be, are we going to saying this, is P hat is statistically significant from this, from P naught, okay, P equals 0.5. Okay. Well, sometimes we use a P and P naught to indicate that this is just our old data. Okay? Well, so it is how we are going to show all that, okay? So you understand the concept, and this is like in the courtroom that the prosecutors come in, okay? They are going to provide the evidences that, oh, this accused person did this, did that, so I claim that this person is guilty, okay? Is it really beyond your doubt? Are you convinced that, so is this person guilty? So same thing, same idea, okay? So what are we going to do over here is, first, we are going to use Z, in other words, Z scores. So that means we are going to use normal distribution. Normal distribution, so we have to establish the case is that, okay, so it is okay for us to use normal distribution, because for now, nothing states that it is going to be a normal distribution, okay? So we have to establish that, number one, n times p times 1 minus p is greater than or equal to 10. But guess what? We have to adjust a little bit, because we do not know the true value of p, correct? Okay, we do not know the true value of p, therefore in our case we have to switch to that. Okay? And the next thing is we have to show that this sample is random simple okay, and this one just we have to accept that there was people who was selected randomly, okay, and the other one is maybe simple random. That sounds a little better, okay, rather than random simple random sample. The third case is that we must understand these people are independent. In other words, one person's opinion does not affect the other person's opinion. Okay? So how we are going to say that? So here n equals 1,000 is less than 5% of population. Here the population is in terms of this statistics. So who a researcher asked what? This is Americans, 1,000 people. They didn't say anything specifically, so we are going to assume that that is going to be just the US adult, okay? US adult to give this kind of opinion, okay? So definitely 1,000 is less than 5% of that, okay? So once we establish that, once we establish this, we are going to really state now formally, okay? So what do we state? We are going to pick up what H naught is. H naught is what? Always equality. Well, this is kind of a little bit of a awkward case that what does it say? What you see here, 534 out of 1,000 people in the sample. This is our sample proportion. So this one has to be p hat. And it is asking that, can you regard this one is that, can you believe that more than 50% people are in favor of this banning cell phone while driving? So we are going to choose p equals 0.5. It does not say explicitly that p is 0.5. No, you have to just catch it from the sentence, okay? So p equals 0.5 and H naught. Alternative hypothesis is this greater than 50%? So this is greater than 0.5. Okay, that is it. Therefore, it will bring a right-tailed test. And then again, whatever we do at the end of the process, we are going to reject H naught, or we do not reject H naught. We do not use the word keep, or do not or use the word accept. Okay, we reject or we do not reject. Okay, what kind of evidence is going to make us reject or not reject? Okay, yeah, that's the thing. What kind of evidence and how you are going to use the evidence. Okay, so over here, the evidence is going to be here, sample proportion, that is 534 out of 1,000 and 0.534. Okay, so what? Well, this is only beginning of the story. Okay, so I want you to pay attention to this. So this is our evidence. But again, this one can be just coincidental, okay? It just happens to be greater than 0.5, or it's going to be the new norm rather than 0.5. Well, that is how we are going to reject or not to reject. Here is right-tailed test. Well, our level of significance, okay? Significance is going to be alpha, unspecified, just alpha. So this is what we are going to do. We are going to make the normal distribution based on our old data. Okay, everything on old data. Therefore, because we already tested the n times p times 1 minus p is greater than or equal to 10, you can do it easily. So this is normal distribution. And we are going to establish this normal distribution based on our old data. Okay? This is true until it's proven otherwise. Anyhow, all right? So the p, the right in the middle, u as like a 0.5. Okay? And then you start from here. We are going to think about what is the standard deviation over here. The standard deviation over here is p times 1 minus p over n, correct? Okay, so plug in over here. P is 0.5 again and again. When you see p, we are going to use p naught. we are going to use p hat only one time. I'm going to show you, okay? Because we still say this is a status quo, okay? So we believe that one is still true. So that one is use everything, just p naught. So 1 minus p also 0.5 and divide by 1000. Okay, so that is approximately 0.016. 0.016. Okay, so that is the sigma. And then, so you can alright, we have normal distribution based on our p naught, okay, that is, so mu is 0.5, and so here is the sigma is 0.016. Yeah, we use just p hat over here, but okay, everybody understands, okay, everybody understands, so we can omit that. Mu is 0.5, this is this, so the 1 sigma away is what? Is 0.516, okay, and the next one again 0.516, 0.016 to 235, 0.532. Okay, keep going. Well, what is the place over here? This p hat is 0.534. So we are going to compute the z-score of that. Okay, so the z-score for p hat. This is the only time we are going to use p hat in our calculation. So what is z-score for p hat? That is p hat minus what? This is z-score is x minus mu over sigma, correct? So mu is sigma, so this is 0.534 minus 0.5 over 0.016. So what is that? That is 2.15. 2.15. Okay. You can look at, once you compute this z-score, yes, that is already, so you can see this. Once you compute z-score, you can say, that means this is just mu outright from p, but this is standardized, this sampling distribution, right? Standardized one. So this is going to be 0, sigma is going to be 1, and this is 2.15. Okay? So let's look at that. 2.15, this is what? Further than 2 sigmas away. Isn't that right? Further than 2 sigmas away. So empirical rule says what? Empirical rule says this is further than the 2 sigmas away. Will have all 95% of data is concentrated over here. In other words, 95% of those all the samples you can think of, okay, over here, those individuals are the samples of 1000, okay? So over here, all these 95% of samples are within 2 sigma. But this one turns out to be more than 2 sigmas away. So that means the outside of 95% is 5%. So this is 2.5%. This area is 2.5%. And this area also 2.5%. Therefore, what it shows over here is that this sample is beyond 2 sigmas away. So in other words, we use the word unusual, right? Okay, this is an unusual case of those sample sampling distribution over here, sampling distribution of sample proportion. Okay, so what can you say? Well, what do you have as an evidence is very unusual. Why this is unusual? Because we set up everything based on this old data. Therefore, what can you say? What is a logical way to say it? Well, so that means this old data is not true anymore. So what do? We do reject. Okay, we do reject the H naught. That's the case. So this is just philosophically, okay? So how many sigmas away is far away enough? That depends on the level of significance. Okay? So level of significance. So when alpha is, so over here, alpha is 5% or 0.05, okay? And if this is a right-tailed test, so right-tailed test, that means this area is 0.05. Yes, this area is 0.05. So what is this z value? Z value is 1.645. Earlier we saw that 2.15. This is greater than 1.645. Yeah, empirical rule says just 2, but if you use normal standard distribution, that one is going to be, or standard normal distribution, and then that one is going to be a little different, okay? This is going to be 1.645, and this area. So this one comes from level of significance. And you compute, and the z-score of this sample proportion what you have belongs to here, belongs to this shaded region. Yes, we have the shaded region. We call this a critical region. Critical region. So you find this sample proportion and you compute the z-score of this sample proportion using this old data. Okay, other things are old data. This is the only one that your evidence is over here, and this z-score falls in this critical region, and then we say that this is far enough from the norm. Okay, far enough from the norm. Therefore, we do reject. Okay, if this is a case like over here, like a 2.15 is going to be here, right? 2.15 is over here. So in this case, we are going to do reject H naught. Of course, you compute the z-score. Z-score is outside this critical region, and then what? We do not reject. Okay, so that is the whole process we go through. Okay, so from next example, we are going to calculate everything. So this is just a philosophical thing, all right? So from the one thing, we use p hat only one time. We set all the z-scores based on p naught, okay?